In this episode, we're going to do a skills integration challenge. I'll show you how to do it, and we'll talk a lot about the concepts along the way. We have a router, we have an ISP cluster, we have a web server that are completely configured for us. What we have to do is create a new IPv4 addressing scheme that will accommodate 4 subnets using the 192.168.0.0/24 network. The IT department requires 25 hosts, the sales department requires 50 hosts, and the subnet for the rest of the staff requires 100 hosts. A guest subnet will be added in the future to accommodate 25 hosts. We must also finish the connectivity or the basic security settings and interface configurations on the router. Then we have to configure the SVI interface and basic security settings on the switches. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Skills Integration Challenge. Here I have the Packet Tracer Lab open. On the left side, I have our work area where our topology is, where we're going to configure the devices. On the right side, I have the instructions. The bottom right, I have the original Packet Tracer window. I keep that open to use the check results button to check my progress, to look and see what I'm missing at the end of the lab. The upper right here is the Word document of those instructions. Why I use the Word document is there's a number of fields that we have to enter as we work through the lab, especially with our IP addressing here. This allows me to save that information in the Word document. We have our packet tracer. As you can see, all of our devices are listed here. We have a couple routers, R1, the central router, 3 switches, and 4 PCs. When we look here, we can see that we are missing a number of fields. A number of fields are empty. Looks like all the IP version 4 addresses, or the majority of them. Then we have a scenario here, a background scenario. What we're looking at here is we have a couple of routers and servers that they're all configured, but now we need to go ahead, subnet our network, make smaller networks out of our one big network with certain requirements. We can see the requirements here. The IT department has 25 hosts. The sales department needs 50. Staff requires 100 hosts, and we're going to have a future network of 25 hosts. 4 different networks there, all pretty much having different requirements. Then we got to finish basic security, configure our interfaces on R1, and then configure SVI on the switches. Here we have our instructions. IP version 4 addressing. Use the 192.168.0.0/24 network to create the subnets. Once again, here are our requirements. Staff needs 100, sales needs 50, IT needs 25, and the future guest network needs 25 hosts. Look and see, they are listed in the order of most hosts to least hosts. That's the order that you should go through and do your variable length subnet masking here. What I've done off camera is went ahead and did all the variable length subnet masking. To do that, there's kind of at least 2 methods out there. And what we wound up doing is finding the requirements and then subnetting our subnets. There's a couple of methods, like I said, that allow you to do subnetting. One is the magic number method. That one works. There's the KISS method of subnetting, which is keep it simple, silly subnetting. That's my preferred method. That one is also out there. And there's a couple other ones out there. Whichever one works for you is that correct method. Whichever one you can understand how to do subnetting, that's the method that is right. What I've done is over here in a Word document, I've documented a bunch of that information after I went through and did all that variable length subnet masking. I have our original network up here, 192.168.0.0/24. Here's the first requirement. The staff network needs 100 hosts. I went through and I processed all that information. Our network address here is 192.168.0.0/25. That's the network address for our network. The broadcast address, the last address in this network, comes out to be 192.168.0.127. Then from the network address and broadcast address, we can figure out what the first assignable address is and the last assignable address. Once again, remember, you can't use the first address in a group of IP addresses. That's the network address. Can't use the last IP address in the network of addresses because that's the broadcast address. It's going out to all the devices. To find the first assignable, you add 1 to the network address. If we add 1 to 192.168.0.0, that gives us 192.168.0.1. To find the last usable address, what we do is we subtract 1 from the broadcast address. Our broadcast address is 192.168.1.127. We subtract 1 from that. That gives us 192.168.1.120. Or sorry, let's start that one over. 192.168.0.126. Those are our addresses. Network address, first assignable, last assignable, and broadcast address. Then, based upon that information, especially the 192.168.0.0/25, that /25, our new custom subnet mask is 255.255.255.125. If you convert this number to binary, 255.255.255.128, you're going to get 25 ones followed by 7 zeros. 25 ones followed by 7 zeros, which is our slash number up here on our network. With all of this information, the total number of IP addresses available, so the total number of IP addresses is 128. That includes the first address, which is the network address, which represents all of the devices on our network. The last address is the broadcast address, which is an address that is used to send communications to all devices on the network. You can't use the first one, you can't use the last one, and so you subtract 2 from the total number of IP addresses that are available. That gives us a total number of 126 assignable addresses. 126 addresses we can assign to hosts on our network. After I figured out our staff network requirements, I then started with the next requirement. The broadcast address for the staff was 192.168.0.127. If I add 1 to that, that gave me my network address here of 192.168.0.128, 1 more than the broadcast address of the previous network. Went through, did my variable length subnet masking calculations, and it came out to be, it is a /26 address. With a /26 address, the network address is the 192.168.0.128, gives us a broadcast address of 192.168.0.191. From the network address and broadcast address, we can figure out what the assignable addresses are. First one is 1 more than the network address, 192.168.0.129. And the last assignable, 1 less than the broadcast address, 192.168.0.190. New custom subnet mask, a /26, convert that into binary, gives us 26 ones followed by 6 zeros. Calculates out to 255.255.255.192. Gives us total IP addresses of 64. Total assignable addresses is 62. 62 is more than our requirements of 50. Just double checking that everything works. Our IT network, here's our IP addressing information. Our new custom subnet mask is 255.255.255.224. 32 addresses per subnet, 30 usable. And then our future network, our guest network, here's all of that information also. Notice what the last or what the broadcast address is of the guest network, 192.168.0.255. If we add 1 to that, you can't have 256, so that starts over. We increment the next column by 1. That is a completely different network than what we are given up here. We are given the 192.168.0.0 network. If we add 1 to the broadcast address down here, we get 192.168.1.0. We are using all possible IP addresses for our 4 subnets here in our network. We have to document the IP addresses that have been assigned in the addressing table. I'm going to scroll up here, look at our addressing table, and see that we do need several of these fields filled in. On R1, G00, we need an IP address. What I'm going to do is I'm going to look at my topology quick. I'm going to see, once again, we are looking at router 1, G00. I'm going to click in the window, and then I have to find which one of these is G00. I'm just going to mouse over it, starting at the top. Oh, I got lucky. The top one here is G00. That is the staff network. That is the 100 host requirement. If I pull up the numbers I came up with, that's the first one right here. That was going to G00. And we need to give it an IP address. Now, we can't assign it the first one, can't assign it the first address, that's the network address, can't assign it the last address, that's the broadcast address. The first assignable is 192.168.0.1. Typically, most network administrators give that first usable IP address to their default gateway. The default gateway is the exit off of your network. That's that router interface on that local area network that allows us to get off of our network and onto other networks. I'm going to take the first assignable address and assign it to the G000 interface, 192.168.0.1, and then it says slash prefix. You could put the slash 25 in there because that's what we calculated out, was the slash 25 is our subnet mask. But I like putting out the new custom subnet mask. I like writing out the 255.255.255.128. The reason for that is whenever I'm going to use this IP address, in this particular instance, I'm going to be setting the G00 interface with that IP address. You don't write the slash number. What you do is you write the custom subnet mask, 255.255.255.128. If I write the slash 25 there, then I have to go and convert that later into the 255 numbers. But if I write it down right away, I'm good to go. And I'll do that for the routers, for the switches, anything I have to set an IP address for, the IP version 4 address, I'm going to go ahead and put down that custom subnet mask. 255, 255, 255, and once again, our custom subnet mask is a .128. .128. There we go. Onto G00. I'm going to look at my topology one more time. Here, first one here, G00 is the staff network of 100 hosts. Once I clicked in the window here to make sure it was active, I'm going to mouse over the second one here, and G01, that's the one we're looking at using here. G01 is on the sales network. I'm going to pull up my IP address information. Here's the sales network. I'm going to give the G01 interface, the router interface on that LAN, the first usable IP address. That'll be our default gateway for all the hosts on that network. First usable IP address, 192.168.0.129. 192.168.0.129. 255.255.255.192. Then we need the G02 address. G02, pop over to my topology, click in the window, make sure it's active. Hopefully it's this one. Mouse over to triangle, just let it sit there. G02 is on the IT sales network. We are looking at the G02 address. Come back to our IP addressing information. Here's our IT network. I'm going to give it the first assignable address, 192.168.0.193. 192.168.0.193. And then our custom subnet mask, right here, 255, 255, 255.224. 255.255.224. That takes care of all the information on R1. Let's scroll down. Central router, all the interfaces have all their IP addressing information. That looks good. Down to the switches. The switches need, I scroll up here, the IP address and their prefix or subnet mask, and they also need the default gateway. We need to fill in all six of these fields right here. Starting with S1. If we look at our topology, we can see that S1 was up here on the staff network. Here is our IP addressing information. Here's our staff network. What I'm going to do is I'm going to give that switch virtual interface, that VLAN 1 IP address, I'm going to give it the second usable IP address. Instead of having the be a different one, I'm just going to give it the second usable IP address. First usable address was 192.168.0.1. Add 1 to that, that becomes 192.168.0.2. That's what I'm going to give to the VLAN 1 interface on switch 1, 192.168.0.2. And then I'm going to put the subnet, the new custom subnet mask in the forms of 255s instead of the slash number, because I'm going to have to put that in when I set that IP address. I'm going to have to put it in the 255, so I'm going to go ahead and do that. Once again, our new custom subnet mask is right here, 255, 255, 255.128. 255.255.255.128. And our default gateway. The default gateway for the staff network is that router interface. The router interface on the router on our local area network. If we look back up here, that was the G00 interface, or the first assignable. And this is part of the reason why people give it the first assignable address, because it's easy to remember. You can figure out what your network address is, just add a 1 to it, that's your default gateway. Back down here on switch 1, our default gateway then is 192.168.0.1. On to switch 2. Look at our topology again. Switch 2 here is on the sales network. Our IP address information right here, sales network. I'm going to give it the second IP address again. First assignable was a .129. Second would be a .130. 192.168.0.130. And our custom subnet mask for the sales network, 255, 255, 255.192. 255.255.255.192. And then the default gateway for S2. S2 once again is on the sales network. The router interface that's on the sales network, we gave it the first assignable IP address, the first usable IP address, and that is our default gateway, 192.168.0.129. 192.168.0.129. Now, if you notice, I'm not putting the subnet mask in for the default gateway. The reason is I'm not setting that address there. If I was setting that address, then I'd put the subnet mask in there. But I'm not setting that. I'm connecting to it. I'm directing it to that already established address. And that's one way you can know, do I need to put the subnet mask or not? If I'm setting that address for the first time, you need that subnet mask. If I'm connecting to that address existing somewhere else, all I have to have is the address. You don't need to put the subnet mask. Switch 3, I'm going to look at our topology. Switch 3 is down here on the IT network. Our IP address information for our IT network is right here. The first assignable is .193. I'm going to set up the SVI with the second assignable. 193 plus 1 gives us 194. 192.168.0.194. And then our subnet mask on the IT network here is 255, 255, 255.224. 255, 255, 255.224. And the default gateway on the IT network is the first assignable. We assign that to the router interface, 192.168.0.193. 192.168.0193. Okay, there we go. I got it typed right. That takes care of all of our switches. Last ones we have to do here is the IP version 4 addresses for the NICs in the PC. Let's take a quick look at our topology. If we notice, the staff network has a PC named staff, sales network has a PC named sales, IT network has a PC named IT. Simple naming conventions, great for this exercise. I'm going to pull up my IP addressing information, jump up to the sales network, staff. Staff is first. And what I'm going to do is I'm going to assign the third usable IP address. The first usable IP address, that was the default gateway or the router interface. The second usable or assignable address, that was the switch virtual interface on the switch. The third one is going to be the PC. Looking at our staff network, the first assignable address is 192.168.0.1. That's the router. .2 is the switch. We're going to assign .3 to the PC. 192.168.0.3. And because we're assigning the IP address, I'm going to go ahead and put the custom subnet mask down in the forms of 255s, which is 255.255.128. 255.255.255.128. The sales PCs on the sales network, I'm going to give it the third IP address again. .129 is the default gateway. .30 is the SVI on switch 2, and .31 will be our PC. .131. 192.168.0.131. And our subnet mask is 255.255.255.192. 255.255.255.192. Our default gateway, I forgot the default gateway for the staff PC also, but right now I'm on the sales. Our sales, the default gateway, once again, is the router interface that's on our local network. We assign that the first assignable address to the router. Our default gateway for the sales network, 192.168.0.129. 192.168.0.129. Let's go up and fix the staff PC quickly. On the staff network, the first assignable is our default gateway, assigned to the router, 192.168.0.1. 192.168.0.1. And that leaves us, the last PC we have to do is the IT PC. Yeah, the IT PC. That is on the IT network. We're going to give it the third usable address. 193 is the default gateway. 194 is the SVI on switch 3. So that was 193, 194, 195 is the PC address. 192.168.0.195. And the subnet mask on the IT network, 255.255.255.224. 255.255.255.224. Default gateway on the IT network is the first assignable. That's on our router. 192.168.0.193. 192.168.0.193 at that point in time. I'm going to go up, double check, make sure I have all the fields filled in. And we are looking good. So I did the documentation part of the IP addresses. Last thing here is record the subnet for the guest network. I'm going to pull up my IP addressing once more. And here's the guest network, the information I figured out when I did our variable length subnet masking, VLSM. Here's our network address. The subnet or network address is 192.168.0.224/27. That's the address they're looking for. That's the address here, 192.168.0.224, and then /27. Now, yeah, I could put the subnet mask in there as 255s, but I'm not going to be entering in anything. It's future use, so we're not using it at this point in time. On to the next part of our instructions, PC configurations. Configure the IP4 version address, subnet mask, default gateway settings on the staff, sales, and IT PCs using our addressing scheme that we came up with. Assign the IP version 6 unicast and link local addresses and default gateways to the staff, sales, and IT PCs accordingly. I'm going to scroll up here to our chart, have our IP addressing information right here. We're going to start with the staff PC. Go ahead, click on the staff PC, opens up our configuration window. I make it a little bit bigger right and left just by default, and click here on IP configuration. Opens up our IP configuration window. Notice we have the IP version 4 addresses right here and IP version 6. That's why I'm going to set them both at the same time here. Okay, we are on the staff PC. Staff PC has an IP address of 192.168.0.3. 192.168.0.3. Subnet mask of 255.255.255.128. I have to change that last octet there. It took the default class subnet and put it in there, but we are subnetting our network, and so that default class won't work. We can then just simply go and change that at that point in time. And the last field we have to enter for IP version 4 is our default gateway. Looking at our chart, our default gateway is 192.168.0.1. 192.168.0.1. There we go. Invalid entry. Oh, I had a typo in there. 192.168.0.1. And that takes care of our IP version 4 information. Now we need to do IP version 6. IP version 6, here is our global unicast address. Go ahead and enter that in, 2001 colon DB8 colon ACAD double colon 2. Our prefix then is 64. And then our default gateway for IP version 6 is FE80::1. FE80::1. That takes care of our IP version 6 information. The staff PC is done. I'm going to go ahead and close this window. Looking at our sales PC. Once again, I make it a little bit bigger, going right and left. Click on IP configuration, IP version 4 information. For the sales PC is right here. I'm going to go ahead and enter that in, 192.168.0.131. Our subnet mask, 3255s by 190 with a .192 at the end, .192. And our default gateway is 192.168.0.129. 192.168.0.129. That takes care of our IP version 4 information. IP version 6, once again, make sure it's on static. Here's our IP version 6 information. I'm going to go ahead and enter that in, 2001 colon DB8 colon AC8. Come on, ADB. Okay, make sure I type that in, ACAD. That looks good. Colon 2, double colon 2, and then our slash number of 64. And our default gateway, once again, the link local address of FE80::1. FE80::1. That takes care of all of our IP addressing for the sales PC. And finally, the IT PC. Open that up. IP configuration. Here's our information. Here's our IP version 4 information for the IT PC. Go ahead, enter that in, 192.168.0.195. Our Subnet mask 255, 255, 255.224. 224. Our default gateway 192.168.0.193. So, yeah, that's right. 192.168.0.193. That takes care of all of our IP version 4 information. We just have IP version 6 left. Here from our addressing table is our information. Go ahead and enter that in 2001 colon DB8 colon ACAD colon 2 double colon 2 with a slash 64 and the default gateway of FE80 colon 1 FE80 double colon 1. Just confirm all of our information looks correct. There we go. And saved it off. That takes us through the PC configuration part. We are done with that. On to router 1 configurations. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Router 1. First step here is to configure the device name according to the addressing table. I'm going to go ahead and click on Router 1 here. We're in our CLI here, hit enter. We can see that we are in user exec mode. First step here is configure the device name according to the address table. Scroll up here, addressing table says we will use R1 as our device name. We are in user exec mode, type enable to get into privilege exec mode. Then to do our configurations, we need to get in the global configuration mode. That command here is config T. Now we can go ahead and set our host name. Host name is the command to do that. Put a space and then what we actually want to call it. Once again, we want to call it R1. Hit enter. Notice our host name changed. We went from router to R1. And in typical Cisco fashion, especially for their iOS, if you do something correctly, it will not give you feedback. If you type in something wrong, like if I would have spelled host name wrong, it would let you know immediately that you did that wrong. It'll give you some feedback. Cisco's iOS, if you did something good, no news is good news. Second step, disable DNS lookup. The command here to do that once again is no space IP space domain dash lookup. That takes it there. No news is good news in the Cisco world. Entered that in correctly. Assign Cisco ENPA55 as the encrypted privilege exec password. Enable space secret to encrypt it and then our password. Capital CISCO ENPA55. Verify that that's the correct password. Yes, it is. That takes care of step 3. On to step 4. Assign Cisco Con EA55 as the console password. So we have to get into our console port configuration. That is a line command, line con 0. There's only one console port. There's only one port on our device we can plug our console cable into. That's the first one. And of course, computers start counting with 0, line con 0. Right, hit enter. Notice our prompt has changed. And then we need to set our password. Password here. Password of capital CISCO CONPA55. That set our password. And now we have to enable it for the login. That command is simply login. Go ahead, hit enter. Okay, that takes care of that. Require that a minimum of 10 characters to be used for all passwords. Exit out, back in the global configuration mode, and that is the security setting. Starting off with the command security, then passwords, because we're dealing with the passwords at that point in time. We want to set the minimum length, so min-length, and then the number we put there is the minimum length, and our requirement was 10. Oh, I got to spell security correctly. I up arrowed, left arrowed over, did my spelling correction, hit enter. No news is good news. Notice when I spelled security wrong, the operating system did not recognize it. It gave me feedback that my input was wrong. This is where the idea of no news is good news. It gave me news. I did something wrong. I went back, I corrected it. I spelled security correctly, and no news is good news. I entered it in correctly. Okay, that takes care of this one. Encrypt all plain text passwords. We are encrypting those passwords on the device. That is a service we are going to run. So it is service is the first word. And then we're dealing with the password dash encryption. Hit enter, and of course, no news is good news again. Create a banner of the day that warns anyone accessing your device is bad and prohibited. That is our banner message of the day. Starting off with banner, MOTD, space, and then we start off with a delimiter. You got to have that delimiter at the start and at the end of your message and nowhere in the message. I typically use the $. Then we put in our message on authorized access prohibited, period. And then our same delimiter to close this, I put it in a $. I hit enter. No news is good news. On to the next one. Configure and enable all gigabit Ethernet interfaces. Configure the IP version 4 address according to your addressing scheme. Configure IP version 6 according to your addressing scheme. Okay, there are 3 different interfaces. And we will go ahead and enter those in. I'm going to do IP version 4 and IP version 6 at the same time. Up here on router 1, gig 00, here is our IP version 4 address. Here is our IP version 6 address. And then our link local address. We need to enter in all 3 of these addresses. Back over here on router 1, we're in global configuration mode. We need to go into the interface. So interface G0/0. And then we set our IP addresses. For the IP version 4 address, we start off with the command IP space. We're dealing with the address. So next, the option word is address. Then we actually enter in our address, 192.168.0.1, followed by our subnet. And this is why I wrote down the 255s instead of the slash number. I can just go ahead and type those in. 255.255.255.128. No news is good news. On to entering in our IP version 6 addresses. Start off with the command IPv6 because it's a different protocol than IP version 4, so you got to differentiate that. IPv6 does that. We are setting an address, and our address here is 2001:DB8. :ACAD:1, and we put our prefix, the slash number at the end to set our global unicast address. No news is good news, and we have to set our IP version 6 link local address. Command here once again is IPv6 space address. Then we put in the link local address FE80:1. Instead of the prefix for a link local address, what you do is you put in link-local. That sets that up as our address. Go ahead, hit enter. You're good to go. G00, all set. We entered in all 3 of those addresses onto G01. I can simply just enter in interface G0/1, and it switches me to the G01 interface. I can go ahead, enter in my IP address information, IP space address space 192.168.0.129 with the subnet mask 255.255.255.192. No news is good news. IP v6 2001 colon db8 colon acad colon 1 double colon 1. I put in our prefix /64, entered that in, and I forgot the keyword address. Up arrow once, left arrow over, address. There we go. See the no news is good news thing? News is bad for the Cisco operating system. And on to our IP version 6 link local address. IPv6 address space, that is once again FE80:1, and then the option of link local, no prefix in there. Sets up our third address on G01 that, according to our addressing table, takes care of all the addressing. And finally, we just have to do G02. Interface G0/2, and we just have to enter in our IP information. So IP space address space 192.168.0.193 with a subnet mask of 255.255.255.224. No news is good news. Our IPv6 unicast address. There we go. IPv6 space address 2001 colon db8 colon acad colon 2 double colon 1. I do have a typo in there. I have quotes instead of a colon. I'm going to left arrow back, change it, right arrow, and then put my /64, my prefix at the end. No news is good news, and we have to do our IPv6 link local address. So IPv6 space address space FE80:1 with the option of link -local. There we go. We have now set all the IP addresses for router 1. And for those of you at home keeping score, my completion is at 50% of the lab. Down here in the bottom right, we are at 50%. Okay. We went through this bullet point, setting our IP version 4 and IP version 6 addresses. Next step is we have to configure our SSH on R1. Now, there are a couple steps to configuring the SSH. First one we have to do is set the domain name. Setting the domain name is in global configuration mode. I need to type exit once, takes us out to that. The command is IP space domain -name, and then what we want to have be our domain name. Once again, remember, this is case sensitive. Capital C, capital N, capital A -lab.com is our address. Hit enter. No news is good news. We have to generate a 124-bit RSA key. To generate our 124-bit RSA key is part of the cryptology package. So we start off with crypto. Then we are dealing with the keys. We want to generate one. So crypto key generate using the RSA method. General-keys. Then we want to set our modulus to 1024. That is the entire command. Crypto key generate RSA general-key modulus 1024, and it generates the key. If you did this on a real actual device, this would take somewhere between 10 and 15 seconds. Here in our simulated packet tracer environment, it finished it in less than a second. Once we're done generating our 1024-bit key, we have to configure the VTY lines for SSH access. Right now, they're set up for any method. We have to specify it's just SSH and not anything else. We have to go into our VTY lines. That, once again, here is line space VTY for virtual terminals. And then we have to do a range. We have to do 0 to 4 in here. We have to set all the first 5 of them. If you do just 0 here, 1 1 through 4, the last 4 there, will remain active without requiring SSH. So you need to make sure you put that range in there, 0 to 4. That command, once again, was line space VTY space 0 space 4. Notice our command prompt has changed again. We are now in line configuration mode. And we have to change the transport for SSH. Transport is our command. We are using the input. We're changing the input to SSH. So transport input SSH. Go ahead and hit enter. No news is good news. Then we have to use local user profiles for authentication. We want to set it up to say, okay, we're going to go and create a user. Actually, here in the next step, we're going to create that user. We want you to use that user that is local to us. It's not on any other authentication server anywhere else. It's local to the device we're working on. It's local to R1. That command here is login local. There you go. No news is good news again. Next step here, last step for creating an SSH password or enabling it, is creating that user. These first 4 steps actually set up SSH, but now we have to create the user so we can log in. Now we have to get out of line configuration mode. That's an exit. We're in global configuration mode. Here we have username. I hit tab to finish completing it. Username of admin1, capital ADMIN1. We want a privilege level of 15. Option word of privilege 15. And use encrypted password of admin1PA55. So we're going to use the option of secret, and then our password, capital ADMIN1PA55. That is our command. Go ahead and hit enter. Notice once again, no news is good news for us. That takes care of configuring SSH here on R1. Down to the next step. Configure the console and VTY lines to log out after 5 minutes of activity. We have to go back into our VTY 0 to 4. Line space VTY space 0 space 4. Our prompt is changed. We are now in line configuration mode, and we have to change the logout after 5 minutes activity. And that command here is for exec timeout, logging you out of the executive privilege mode. So exec-timeout, and then the number of minutes and the number of seconds. Exec-timeout space 5 space 0 is the command I'm entering. I hit enter. There we go. No news is good news. And then the last thing we need to do is block anyone for 3 minutes who fails to log in after 4 attempts within a 2-minute period. Okay, that is part of the login process. And so we start with the command of login, and then the option here of block for, because that was, we wanted to block it for 3 minutes. Block dash for 3 minutes, but we have to have in seconds. 3 minutes times 60 is 180. Enter in 180 for 180 seconds or 3 minutes. After 4 attempts, and then we have attempts space 4 within a 2-minute period, and then the option of within 2 minutes. Now, once again, we need seconds. 2 minutes. 2 times 60 gives us 120. There we go. Our final command, login space block dash 4 space 180 space attempts space 4 space within 120. Go ahead, hit enter. And no news is good news at that point in time. That takes care of the last step here in our R1 configuration. Now to switch configuration. Configure the device name according to the addressing table. If we look at our topology, we actually have 3 switches here. Switch 1, switch 2, switch 3. Configure the SVI interface. Configure the default gateway. Display the DNS. Assign passwords. This looks like all these steps need to be done on each one of the devices. What I'm going to do is I'm going to do S1 first. Instead of going back and forth, assigning the host name on all of them and then going through and doing the next one, I'm just going to do all of those steps on S1, then go to S2, do all those steps. Over here, I go ahead and click on S1. Open this up. Configure the device name according to the addressing table. Just scroll up here once again. S1, S2, S3. That's actually what they have it labeled in Packet Tracer. But when I hit enter here, we can see my device name is switch. It's still that default setting. Go back down here to our switch configuration. I'm going to set our device name. We are in user exec mode. Type in enable to get into privilege exec mode. Then the host name needs to be in global configuration mode. Type in config T. Takes us to our global configuration mode. Changing our host name to S1. There we go. Once again, notice no news is good news at this point in time. Configure the SVI interface with the IP version 4 address and subnet mask according to your addressing scheme, and then configure the default gateway. I'm going to go up here, scroll up to our chart. Here's our information, IP address, subnet mask, and our default gateway. Now, it's on the interface of VLAN 1. You need to go into that interface. So int space VLAN 1. Our prompt has changed. Notice we are in interface configuration mode. Set the IP address. So IP space address space. Looking over at our addressing table, 192.168.0.2 with a subnet mask of 255.255.128. Push enter. No news is good news. And we have to set the default gateway. Default gateways are not assigned to an interface. They're assigned to the entire device. We need to get in global configuration mode. But before I do that, one last thing I have to do is actually activate the interface of VLAN 1. To activate it, you do a no shutdown. No shutdown, as long as I'm here, hit enter. Notice for VLAN 1, our interface has now went up and our line protocol has now went up. If I wouldn't have done the no shutdown, that would have been down. We would have to come back and do some troubleshooting. Exit out once to get us into global configuration mode. That's where we're going to set our default gateway. The command here to set our default gateway is IP, because we're dealing with the IP protocols, default-gateway. And then the actual IP address of the default gateway, which is 192.168.0.1. Hit enter, and no news is good news at that point in time. That takes care of configuring the SVI and default gateway. Disable DNS lookup. Command to do that once again is no space IP domain dash lookup. No news is good news. Assign Cisco ENPA55 as the encrypted privilege password. Okay, here we go. Enable space secret space capital CISCO ENPA55. That encrypts that password. The option of secret in there. Next step, assign the password to the console and enable login. Line con 0. There we go. Then we set the password of, what was it again? Capital CISCO CONPA55. And we assign it to the login process. We enable it for the login process, which is just simply the word login. Go ahead, hit enter, and encrypt all plain text passwords. type exit once, and that is the service we run on our device. Command here is service space password dash encryption. And up arrow once, come over here. Let's spell service correctly. Yeah, I typed it in wrong. Cisco operating system, definitely let me know about it. I made the correction, and no news is good news. That takes care of all of the requirements for the switch configuration, but that was just S1. We need to go back and now do that for S2 and S3. Go ahead, close S1, open up S2. Okay, user exec mode, type in enable, get into global configuration mode, config T, configure the device name according to the addressing table. We are on S2, so host namespace, capital S2. There we go, changes our host name, configure the SVI and subnet mask and default gateway. Scroll up to our addressing table. Here's our information for S2. Let's go ahead, enter that in there. Come into, from global configuration mode, go into the interface for VLAN 1. Set up our address, IP space, address space 192.168.0.130. And their subnet mask 255.255.255.192. There we go. No news is good news. We are in our VLAN 1 interface. While we're here, we do a no shutdown to make sure we activate it. As you can see, the interface and line protocol has both went up. Let's type exit once to get us into global configuration mode where we set our default gateway. IP space default dash gateway. And then our default gateway IP address 192.168.0.129. Let's spell default correctly. And finally, no news is good news from Cisco. That takes care of the SVI and default gateway, disable DNS lookup, no space IP space domain dash lookup. No news is good news. Assign Cisco, assign the password as the encrypted privilege exec password. Once again, that is no. Start over one more time. Once again, that is a neat. Come on, let's start over nicely. Not erase. Once again, that is enable space secret space capital CISCO ENPA55. Hit enter. No news is good news. Assign the password as the console password. Enable login. Line space BTY 0 space 4. Set up our password of capital CISCO CONPA55 and enable the login process simply with login. Hit enter. Configure the line, or configure the console VTY ports to log out after 5 minutes of activity. We are in our VTY. Go ahead and say exec dash timeout space 5 is the number of minutes, 0 is seconds. Hit enter. We have to go in and do our console also. Line on 0. I had to backspace for a second. Hit enter, and once again exec dash timeout 5 space 0. There we go. We have that set. And encrypt all plain text words. That's a service we run on our computer. Type exit once to get into global configuration mode. Then it is service space password dash encryption. Hit enter, and no news is good news. That takes care of all of these steps for S2. Go ahead and close S2. Let's open up S3 and get those configuration steps in there. Enable, get into privilege exec mode. Config T gets us into global exec mode. Name our device S3, host namespace S3. SVI, IP address, subnet mask, default gateway. Up here to our addressing table. Here is our information that we'll be entering. Interface VLAN 1, IP space address space 192.168.0.194 with a subnet mask of 255.255.224. There we go. Do a no shutdown on it. Gotta spell shutdown correctly. Notice we went up and up. That's what we're hoping for. Type exit once to get into global configuration mode. That's where we'll set our default gateway. Command here is IP space default dash gateway with our default gateway's address of 192.168.0.193. Takes care of these steps. Disable DNS lookup. No space IP space domain dash lookup. There we go. Assign password as encrypted privileged password. Enable space secret space capital CISCO ENPA55. Hit enter. No news is good news. Assign password as the console password. Enable login. What we are looking for here, once again, was our, what was it, console password. The command here is get us into our console configuration, line space con space 0. There we have it. Set our password here of Cisco con PA55 is our password. Enable it for the login process with the simple command of login. And the next step here, configure to log out after 5 minutes. That's exec dash timeout space 5 space 0 seconds. Hit enter. No news is good news. And of course, I have to go back and do this for my VTY lines also. Line VTY 0 space 4. Gotta make sure you do your range for your VTY. And then it's exec dash timeout space 5 for 5 minutes space 0 for 0 seconds. There we go. And finally, last step is encrypt all passwords. Go ahead and type exit, get us into global configuration mode where we encrypt our passwords, and it's a service we run on our device. We start off with service space password dash encryption. Hit enter. No news is good news. Then we're down to connectivity requirements. We're checking out to make sure everything is working. But down here in the packet tracer window, I'm at completion of 94%. I must have missed something in my completion. I'm going to go ahead and click on results. When I click on results, of course it says my activity is incomplete. Please try again. Here's the assessment. We are got a couple red X's in here. We're just going to start at the top, work our way through here. So on the IT PCs, we have a link local IP version 6 address incorrect. I'm going to go ahead. We're going to go look at that. Go ahead, close that off. Look on our ITPC. IP configuration. Scroll up to our addressing table. And our link local address. Our link local address should be FE80::2. Not what they have here. I'm going to go ahead and get rid of that. Type in FE80::2. Tab to the next field. That took me up to 95%. Takes care of one of my issues. Click check results again. Assessment items. Looking for more red X's. On switch 1 here, I forgot the terminal line timeout on the console port on switch 1. So I need to go and set that on S1 here. So S1 console, the exact timeout I need to set. Switch 1. Hit enter. Log in. That was capital CISCO CONPA55. Logs me in. Type in enable to get into privilege exec mode. Once again, that was capital CISCO ENPA55. There we go. And we have to set our line con. What do we have to set? On switch 1, the terminal timeout on the console port. That's what we have to set. Back on S1. That was for line con 0. Oh, get into global configuration mode, then line con 0. And exec dash timeout. And that requirement, once again, was after 5 minutes, 5:0 for 5 minutes and 0 seconds. There we go. Takes care of that. Click on check results again. Assessment items, scrolling through, looking for any red X's. On S2, the console password I forgot to set. So on S2, I have to set the console password. S2 console password is what I'm setting. Oh, I hit enter. Notice it took me right in without asking for a password. Get into privilege exec mode. Type in enable. Capital CISCO ENPA55. Right there. Global configuration mode. Changes that, and that was for line con 0. We have to set the password of Cisco Conpan 5. Capital CISCO CONPA55. Spell password correctly. Click on check results. Looking for red X's. Up down here on the sales computer, I have to set all the IP version 6 addresses. I have to set all the IP version 6 addresses. That was sales computer, IP version 6 addresses. Scroll up to my addressing table on the sales computer. IP configuration, and I have to set all of my IP addressing information. I'm going to position all my IP addressing information right there. And here we go. 2001 DB8 ACAD. Oh, that should be a 1 right here. Go ahead and make that change. We have a /64. We have to set our link local address here. FE80::1. Nope, it's not ::1. It was ::2. There we go. And then our default gateway, that looks correct. And let's click on check results one more time. Assessment items, looking for any red X's. And here we are on the staff PC. My link local address is incorrect. Staff PC link local address. Staff PC, IP configuration. The link local address I need to configure correctly. Looking here at the staff PC. Here's our information. Here's my link local IP version 6 address, FE80::2. Go ahead, enter that in, FE80::2. Have that entered. Go ahead and close that. If we look down here, my completion is 100%. I'm just going to click on check results. Assessment items. I like seeing all the green check marks there. All green check marks says we have everything completed. Now we can go ahead and do that last step here of connectivity. Use the web browser on the staff, sales, and IT PCs to navigate to www.cisco. Open that up, make the window a little bit wider, right to left, click on the web browser, loads that in, www.cisco.pka, I'm guessing is packet tracer activity. Click go. Click go. It took several seconds, but it finally did. Probably had to do some ARP requests behind the scenes. But notice we are on the IP version 4 page. Then we have to check the Cisco 6.pka. I'm just going to go up here, put Cisco 6 in there. Click go. And now we've changed to an IP version 6 page. That seems to work. Go ahead, get on the sales computer. We'll do the same thing. Make the window a little wider. Click on web browser. www.cisco.pka. Click go. Here's our IP version 4 page. Notice it came in quicker, but probably didn't have to do all the ARP requests. And let's change it to Cisco 6.pka. Click go, and we are on the IP version 6 page. That all seems to be working. Click on the IT computer, make it a little bit wider, right to left. Click on web browser. Enter in www.cisco.pka. There's our IP version 4 page. Let's change that to Cisco 6. Click go. Click go, and here is our IP version 6 page. All the web browsers seem to be working. All PCs should be able to ping all the other devices. Okay, I'm just going to pick one PC to test it out. Let's go with the sales PC. I'm going to close the web browser, open up our command prompt, and I'm just going to start pinging some addresses. I'm going to ping the 192.168.0.1 address. Make sure I type that in correctly and hit go. That one works fine. I'll ping another address on a different network, 192.168.0.129. That one works fine. I'm going to pick the IP address of G02 interface. Ping 192.168.0.193. That seems to work. And I'm going to ping the serial 001 interface. Ping 172.16.1.2. That works successfully. I'm going to pick out some addresses from the central router. I'm going to go and actually ping the IP version 6 address. Ping 2001:DB8:1:1. Hit enter. That works successfully. Let's ping the serial 001 interface. Ping 2001:DB8. :2, :2. That successfully works. Then we have our switches here. Let's go ahead and ping those switches. Ping space 192.168.0.2. Okay, first one's gonna fail. Maybe the second one. There we go. Had to do ARP requests a couple of times to actually get us to working. If I repeat that command, up arrow, hit enter, all four are going to work because that address is in our ARP table. Let's go ahead and ping switch 2, 192.168.0.130. Probably going to have to do an ARP request or two. I'm hoping. There's the first one that timed out, and second, third, and fourth one works. I'm just going to repeat that. All four should work this time. Excellent. Let's ping S3 192.168.0.194. Probably have to do an ARP request as we wait. There's our first timeout. Come on. And second timeout. And we work the X2. I'm going to repeat that command once again. All four working. There we go. And I am going to ping the other PCs. I'm going to ping the staff computer 192.168.0.3. That was staff. I'm going to ping, well, we're the sales computer. Oh, let's go ahead and ping that anyways. 192.168.0.131. Hey, we can talk to ourselves, at least somebody to talk with. Let's ping the IT computer 192.168.0.195. That one works fine. And let's ping the web server. Ping, and I'm going to ping the IP version 6 address 2001 colon EV8 colon CAFE colon 3. There we go. The pings have worked. Basically, I've tested all devices. I pinged all the devices. They all answered me. That was Packet Tracer Lab 17.8.2 Scales Integration Challenge. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.